Hello students, welcome back to the classroom point. In our today's class, we are going to discuss the atomic number, isotopes and other characteristics. In our previous class, we have already discussed the discharge tube experiment as well as the Thomson atomic model. So in the discharge tube experiment, we discussed about how the X-rays are going to generate. We know that when cathode rays hit the metal acquires the negative charge and later it starts releasing the X-rays. These X-rays are completely neutral and not affected by the either electric field or magnetic field. So these are having the high penetration capacity. So apart from these X-rays, let us discuss about some other particles. These are alpha particles, beta particles and gamma rays. So among these three, only alpha and beta are having the particle nature and gamma are not having the particle nature. We know that alpha particles are the helium nuclei. So we can write down this one as He2 plus ions or simply 2He4, that is having the two positive charges. So alpha particles basically positive charged particles, whereas beta particles are just like electrons. Not the electrons, just like electrons, they have the negative charge, whereas gamma rays are the neutral in nature. All these are having the penetration capacity. Among these, the highest penetration capacity is with the gamma rays. Next one, beta particles. Next, alpha particles. So here, as we have shown this alpha particle as 2He4, its atomic number is 2, whereas mass number is equals to 4. So successive loss of one alpha particle and two beta particles will produce the isotopes that we shall see while discussing the isotopes. So now let's begin the concept, that is definitions of the atomic number, atomic mass and their calculations. These are very basic things, but even though without these we cannot go ahead, because these help us in understanding the remaining concepts of the atomic structure in a perfect way. So let us see here. Atomic number. Atomic number is denoted by the symbol or the letter Z. Atomic number means the number of protons present in the nucleus of an atom is called the atomic number, or this can be defined even using the electrons also. The number of electrons present in a neutral atom is also known as the atomic number. Whenever protons are used, not necessary to use the word neutral, but in terms of electrons, if you are defining the atomic number, we must use the word neutral atom. The reason here is protons don't leave the nucleus. We know that protons are present in the nucleus, whereas electrons are present in the external part of the nucleus, that is outer side of the nucleus. So electrons can be lost or electrons can be gained by an atom, but protons usually they don't lose it. So that's why defining the atomic number using the protons is the more accurate way instead of using the electrons. So let us take an example here. For neutral atom, number of protons equals to number of electrons. But if you take the for cation in the sense positive charged ions are known as the cations. So in case of the cations, number of protons are more than the number of electrons. And for anions means they are the negative charged ions are known as the anions, in which case number of protons are less than the number of electrons. So let us take an example here. If you take the hydrogen atom, for hydrogen atom, number of protons and number of electrons, if we take number of protons equals to 1, number of electrons equals to 1, even though the atomic number, let us see the atomic number also here. Atomic number is nothing but the Z. So here it is equals to 1. But if you take the H plus ion, atomic number don't change 1. Number of protons also don't change, but number of electrons, H plus ion is found by the loss of 1 electron. Hydrogen is having the only 1 electron, that electron also lost. So number of electrons are equals to 0. And H minus ion, hydride ion, if you take, number of atomic number is 1, number of protons equals to 1, but number of electrons equals to 2. So that's why defining the, in all these cases, atomic number of protons remains same, but number of electrons gradually changes. That's why defining the atomic number using the protons is the more accurate way instead of the electrons. But whenever the electrons terms you are using, you must use the neutral atom, because only for neutral atom, number of protons equals to number of electrons. Now let us see the mass number. Mass number is denoted by the letter capital A. So mass number of the atom, mass of atom is equals to sum of the mass of all the particles present in the atom is known as the mass of the atom. So we can write down the mass of protons plus mass of neutrons plus mass of the electrons. But we know that mass of electron is equals to mass of proton divided by 1837 times. Means approximately the mass of the electron to be taken as 0. So my electron is considered the massless particle and it is contributing the negligible mass towards the mass of the atom. So that we can neglect the mass of the electron, so that we can write down the mass of proton plus mass of the neutrons. And mass of the proton, even though it is less than the mass of the neutron, but mass of the neutron is slightly higher than the mass of the proton. That is the reason why we can take approximately mass of the proton is equals to mass of the neutron. So we can write down the mass of proton plus mass of the neutron as it is. Mass of the proton means number of protons increase means mass of the proton also increase. Number of protons are nothing but the atomic number. So that I can write down here number of protons plus number of neutrons, that is what called as the mass of the atom. And we also know that protons and neutrons are present in the nucleus. That's why they are called as the nucleons. So Z plus N value is also known as the nucleons. So mass number is equals to nucleons. That means number of protons plus number of neutrons. So let us take some example in how to calculate the number of neutrons also here. Number of neutrons is equals to mass number minus atomic number. So let us take some examples here. 1H1. In this case, Z value, number of protons, that is nothing but the atomic number, and mass number A is equals to 1 and number of neutrons 1 minus 1 equals to 0. Or else in a more elaborated way, let us take the how to represent this type of the symbols. Whenever you take any symbol or any element, so let us take like this. ZXA. The subscript represents the atomic number. Superscript represents the mass number. Whereas this one represents the symbol of the element. So now let's write down the same. Once again I am taking the 1H1. In this, number of protons, number of neutrons, mass number, number of electrons, everything let us calculate. This represents the atomic number, that is nothing but the number of protons 1, number of neutrons 1 minus 1 equals to 0, and mass number is equals to 1, and number of electrons equals to number of protons in the case of the neutral atom, that's why it is equals to 1. And now let us take the 1H2 plus. In this case, number of protons is equals to 1. Number of neutrons, mass number minus atomic number, 2 minus 1 equals to 1. Mass number, this is the mass number 2. Number of electrons means see, hydrogen is having only one electron, it lost the electrons, so that it is equals to 0. So in this way we can calculate the mass number values, and usually mass number, as I said here, it is the sum of the protons plus neutrons. We usually take the mass number as an integer values, but actually mass number for the most of the atom is a fractional one. Why? Because most of the atoms exist in the form of the isotopes, so that isotope mass also, all the isotopes mass also we have to take, and we have to take the average of all the mass of the isotopes. That's why we always get the fractional values. So let us see here how to calculate the average atomic mass. Average atomic mass is equals to formula sigma percentage of isotope into isotopic mass divided by 100. We know that chlorine, let us take an example here. Chlorine exists in the two isotopic forms. Chlorine atomic number 17, it exists as 35 and 37. Chlorine 35 is the most abundant isotope of the chlorine, which comprises almost 75%, whereas chlorine 37 comprises of the 25%. Then the average atomic mass of the chlorine can be calculated as, see, percentage of the isotope, this is 75, into isotopic mass, this is 35, plus percentage of the next isotope, 25, into its isotopic mass, 37, divided by 100, this gives 35.5. So actually chlorine atomic mass for the most of the its isotopes is 35 only. But while calculating the problems, we take the 35.5, means we are including the chlorine 37 atomic mass also. So these atomic masses, whatever these values are there, these values we don't take in solving the problems. That means calculation of the molecular masses and all those. We take only average atomic mass by considering the isotopic mass also. So let us see some questions, how the questions can be framed based on the A equals to Z plus N formula. So let us solve this question. The given question is, consider an imaginary ion 22x3-48. The nucleus contains A% more neutrons than number of electrons in the ion. So what is the value of A? Means what is how many number of percentage of neutrons are extra present than the electrons. So let us take this symbol once again, 22x3-48. So let's write down the number of protons here. Number of protons equals to 22. Number of neutrons, 48 minus 22, that equals to 26. Number of electrons. Number of electrons for neutral atom is equals to number of protons. For negative ion, number of protons plus extra charge. So here we shall discuss the small point also. Calculation of number of electrons. So for anion number of electrons equals to number of protons plus given negative charge. For cation means positive ion. Positive ion means electrons are lost. So for this, number of electrons equals number of protons minus given positive charge. Because cations carry the positive charge, that positive charge we have to subtract from the total number of protons. So we'll get the number of electrons. So here number of protons are given as 22 plus extra charge given as 3, that equals to 25. So what is the difference in this value? Because they said how many more neutrons are present. So number of neutrons extra present. Number of neutrons present more than electrons equals to how many present? 26 minus 25 is equals to only 1. Then its percentage we have to calculate. What is the percentage of that 1 compared to the electrons? So 1 divided by 25 electrons into 100. It gives 4%. So the value of A is equals to 4. So let us see the next question here. An element with mass number 81. So here the value is given A as 81, contains 31.7% more neutrons as compared to the protons. Protons value not given. So what is the percentage of extra neutrons? Percentage of extra neutrons is equals to 31.7% is given. So extra neutrons let us calculate. Then 31.7 divided by 100 means you are cancelling this percentage. So you will get the 0.317 extra neutrons are present. As we don't know how many protons are present, so let us consider that is Z. Z means protons is equals to X. And number of neutrons is equals to X plus extra. How much are there? 0.317 X value. Because this much extra present in addition to this X value. So that's why number of neutrons now becomes 1.317 X. Now mass number is equals to, we know that Z plus N. Mass number is given as 81. 81 is equals to, Z value is equals to X. N value equals to 1.317 X. So 81 is equals to 2.317 X. So X equals to 81 divided by 2.317 is approximately equals to 34.95. So we can consider this one as a 35. As they asked, the symbol of this combination is, so we have to write down 35, that is 35 X 81. We shall see some more other questions. So the question here is, an atom contains protons, electrons and neutrons. If the mass of each neutron is halved and each electron is doubled, then atomic mass of the 12 magnesium 24 is. So let us see here, 12 magnesium 24 is given. Let's write down the number of protons here. Number of protons equals to atomic number, that is 12, and number of electrons also 12 since it is the neutral atom, and number of neutrons 24 minus 12 also equals to 12. And mass number is given anyhow, the mass number is equals to 24. Here what did they do here is each neutron is halved, the mass of each neutron is halved. So 12 divided by 2, the value equals to 6. So mass of the neutrons becomes half. Mass of the protons as it is. So 12 plus 6 is equals to 18. Mass number of protons plus number of neutrons after making the neutrons mass half. And each electron is doubled. As we discussed earlier, electrons do not contribute anything towards the mass of the atom as they are the massless particles. So original mass of the atom is 24. Now the new mass of the atom is 18. Difference is 6. That means this much mass it is lost. So it lost 6. So percentage of the mass lost by this element is equals to 6 divided by total mass 24 into 100. 4 times it goes 25. So how much mass is decreased for this magnesium 24? That is 25% of its mass is decreased. Let us see the another one. An ion with mass number 56. So that here A value is given as 56. Contains 3 units of positive charge and 30.4% more neutrons than electrons. So assign the symbol of this ion. As the number of protons not given, let us consider the Z is equals to X. And what is the electrons? Because here neutrons electrons ratio is means neutrons is 30.4% is more than the electrons. Electrons we don't know, but they said that it contains the 3 units of positive charge, means it is a cation. It lost the 3 electrons. So now number of electrons is equals to X minus 3, atomic number minus 3 electrons lost. So total number of electrons equals to 3. Now number of neutrons, as we don't know, let us consider the number of neutrons which is higher than the number of electrons they said. So number of electrons, how much they have taken? X minus 3 plus extra electrons, extra neutrons are 30.4%. So we can take it as a 0.304 X value. So let us substitute these values in the formula. A equals to Z plus N. A value is equals to 56. Z value is equals to X. But that X value plus number of neutrons value, this value, that is X minus 3 plus 0.304 X. Now if you sum all these values, X plus X 2 and this value equals to 2.304 X minus 3 is equals to 56. Now 2.304 X is equals to 56 minus 3, that value equals to 53. So 2.304 X. Then X value equals to 53 divided by 2.304, that gives approximately 26. So 26 is the atomic number of the iron, so that we can write down the symbol 26. Iron, as they said, 3 units of positive charge and atomic mass was given as 56. So this is the answer for this question. And there is a small correction in the earlier question where 35 chlorine was mentioned. 35 chlorine, please do correct it, it is bromine, and mass was given as 81 for the earlier question. So now let us discuss the isotopes, isobars. and isotones. Isotopes. Isotopes means atoms of same element having different mass are called isotopes. So atoms of same element we said. Same element means atomic number and electrons remain same. So let's take an example here. 1H1 protium, 1H2 deuterium, 1H3 tritium. This is protium, deuterium and tritium. This is the most stable isotope of the hydrogen. Deuterium is called as the heavy isotope of the hydrogen. Tritium is known as the radioactive isotope of the hydrogen. So now here, if you see the number of electrons, number of protons and number of neutrons. Number of electrons are 1, 1, 1 in all these cases. Number of protons also, as the atomic number is same, so that number of protons also same. Number of neutrons means mass number minus atomic number. 1 minus 1, 0. 2 minus 1, 1. 3 minus 1 is equals to 2. Remember every time that physical properties usually depends on the mass number and chemical properties depends on the electrons. As long as electrons remain same, electronic configuration also remains same, then automatically they will have the similar chemical properties. Why? Because only electrons participate in the chemical bond formation, but not the neutrons and the protons. So here, for these elements, as the number of electrons remains same, they have the same chemical properties. When the number of neutrons are different, they have the different physical properties. So here, hydrogen is the radioactive isotope of the hydrogen. Tritium is the radioactive isotope of the hydrogen, which can release the beta rays. Once an element releases the beta rays, its atomic number increases, so it becomes a 2He3. Then how these isotopes are going to produce? Isotopes are produced by the successive loss of one alpha particle and two beta particles. That we have already seen. Once again we shall take that. 88 radium 226. One alpha particle is lost. One alpha particle means helium nucleus, 2He4. So 2 from the bottom you remove that, so that it becomes the 86 radon 222. Then loss of one beta particle gives 87 francium 222. Loss of one more beta particle gives 88 radium 222. So successive loss of one alpha particle and two beta particles produce same atom but with a different mass number. So atoms having the same atomic number, different mass number are known as the isotopes. Usually more stable isotope is highly reactive than the heavier isotopes of that particular element. Now let us see about the isobars. So isobars means atoms of different element having same mass number. known as the isobars. So we shall take an example here. 6 carbon 14 and 7 nitrogen 14. And again, if you write down the number of protons, number of electrons and number of neutrons for these two isobars, number of protons for this carbon is 6, nitrogen is 7. And number of electrons, since both are neutral, it is equals to their atomic number. So here it is equals to 6, here it is equals to 7. Number of neutrons, 14 minus 6 equals to 8. Here 14 minus 7 equals to 7. Again, mass number is same. Mass number both are having the 14. Means nucleons number, that means number of protons plus neutrons value is only the same. Remaining all values are different. Means atomic number is different, electrons also different. Since the atoms which are having the different atomic number obviously will have the different physical as well as the chemical properties. One simple thing to memorize these isotopes and isobars is, for tops are different, bottom is same. For isobars, bottom is different, top is same. So now let us see the isotones. Isotones, atoms of different element having same number of neutrons called the isotones. Only number of neutrons are same, remaining values are different. So let us see here example. 6 carbon 13 and 7 nitrogen 14. So let's write down number of protons, number of electrons, number of neutrons and mass number. Number of protons 6, here it is 7. Number of electrons also 6, here 7. Number of neutrons, 13 minus 6 is equals to 7. 14 minus 7 is equals to 7. Mass number is 13. Here it is equals to 14. So here these atoms are having only same number of neutrons. So A minus Z value is same. Number of neutrons means how to calculate the number of neutrons, that equals to A minus Z. The atoms which are having the same A minus Z value, they are called the isotones. And isotones also, since they belong to the different atoms, they must have the different physical as well as the chemical properties. Now let us see the isoelectronic series. Isoelectronic series means the atoms or ions having same number of electrons called isoelectronic. That series of compounds are known as the isoelectronic series, and the elements or ions are known as the isoelectronic in nature. So let's take an example here. Carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium and aluminum. Their atomic numbers: carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminum 13. So now what happens if 4 electrons are added to the carbon plus 4 electrons? It becomes C4 minus. Add 3 electrons to the nitrogen, it becomes N3 minus. add 2 electrons to the oxygen, it becomes O2 minus. Fluorine, add 1 electron, it becomes F minus. So why are we adding this many number of electrons? Very simple thing. If you add 4 electrons to the carbon, carbon is already having the 6 electrons. In addition to that, we are adding the 4 more electrons. So it becomes total number of electrons in C4 minus equals to 10 electrons. Here 7 plus 3 electrons equals to 10 electrons. Here 8 plus 2 extra electrons equals to 10 electrons. Here 9 plus 1 electron equals to 10 electrons. In case of neon, not necessary to add any more electrons because already it is having the 10 electrons. Then what about the sodium? Sodium is having the 11 electrons. To make its electrons equals to 10 electrons, we have to remove the electrons now. So remove 1 electron from sodium, you will get the Na plus ion. From magnesium, we have to remove the 2 electrons to get the Mg2 plus ion. Aluminum is having 13 electrons, so that it is necessary to remove the 3 electrons to make it is equals to Al3 plus ion. Now let us see their electrons now. Neon is having 10 electrons. Sodium also having the 10 electrons. Magnesium also having the 10 electrons, whereas aluminum is also having the 10 electrons. So here atom or ions having same number of electrons are known as the isoelectronic in nature, and the series of these elements or the ions are known as the isoelectronic series. So dear students, I hope you understand this class and we shall meet in the next class. Thank you.